solve the exponential equation. 9 to the power 1 minus x equals to 1 over 27 to the power negative 2x plus 3. Well, the first thing I notice is that both 9 and 1 over 27, they're powers of a nice common base, 3. So let me start with rewriting the equation that way. That way we will have only one base in the equation, and that's going to make the expressions nicer. We won't have to use natural logarithm or a common logarithm. So 9 is the same thing as 3 square, whereas 1 over 27 is the same thing as 1 over 3 cubed, and that can be written as 3 to the power negative 3. So 3 square, wherever I see 9, I put 3 square, so that 1 minus x is the exponent of the whole thing. And the same way, on the right hand side, I make the substitution. Instead of 1 over 27, I write 3 to the power negative 3. And that negative 2x plus 3 is just waiting outside in the exponent. And then I use an exponential rule that says if you have a base raised to an exponent, and that total you raise to another exponent, you get the same result as if you're multiplying the exponents. And if you don't remember that rule, you can always play with the with small numbers. 5 squared to the third power, like how are that 2 and 3? How do you simplify that? Well, take 3 copies of 5 squared. That's what that cube says. And then each square says, hey, take 2 copies. And you end up having 6 copies of 5 multiplied. And a short way of writing that is 5 to 6. And that 6, how that 6 is related to that 2 and 3 is the product. So what I'm going to do is 2 times left-hand side exponents, 2 times 1 minus x, that would be 2 minus 2x, and the right-hand side exponents can be simplified to negative 3 times negative 2 plus 3. That I can simplify to, what is that, 6x minus 9. So 3 to the power 2 minus 2x equals to 3 to the power 6x minus 9. And having that 3 as the base on both sides is very convenient. If that 3 would be a 5 or something, then we would have to use ln or logarithm base 10 in our calculator. Here we don't need our calculator. So the next step, you don't have to write, but the antidote of an exponential equation, and if you want to bring x down, we want to solve for x, is applying logarithm. And when you apply logarithm, that's undoing exponentiation, right? So if you ask, what's the power? You need to raise 3 to get 3 to the power 2 minus 2x. Well, the answer is in the riddle, 2 minus 2x. Same thing on the right-hand side. Or you can just say, if you have 2 exponential terms, the bases are the same. The only way the terms are the same is when the exponents are the same. In other words, exponentiation is a one-to-one function. And then from here on, once you bring x down, then this becomes a linear equation. And all you have to do is move x's to one side and numbers to the constants to the other side. What do I get? 8x on the right-hand side and 12 on the left-hand side. And I divide by the coefficient of x, which happens to be 8. And this would be the answer.